Good morning, everyone. We are going to go over lesson 7 today. We've previously been talking about parallelograms, and we're going to start getting into triangles. So last time we talked about how to find the area of a parallelogram. And if you recall, we first found the base, then we found the corresponding height, and then we used our nice, easy formula to find the area, and that was base times height. So when looking at the base and the height, can we use any side of a parallelogram as a base? Yes, we can. And once we find the base, how do we identify the height? Well, it can be any segment that's perpendicular to the base, and it's drawn from the base to the opposite side. And remember, perpendicular means it's at a right angle. So let's look at an example. We've got a couple of parallelograms here. We'll do the first one. Each copy has one side labeled as the base B, and then a segment is drawn for its corresponding height, and that is labeled H. So in this parallelogram right here, we are going to find the area. So if the base of the parallelogram B, that you see here, is 2.4 centimeters, and the height, which you see here, is 1 centimeter, how do we find the area? Well, remember our formula is base times height. So base times height in this instance is 2.4 times 1. What does that give us? That gives us 2.4 square centimeters. So our area is 2.4 square centimeters. So let's scroll on down, and then we'll look at some triangles. So remember also, if two polygons are identical and they match up exactly when they're placed on top of each other, they have the same area. So here we've got several polygons that we're going to look at. And what we're going to do is we're going to draw one line to decompose each of these polygons into identical triangles if we can. So let's see how we do that. So let's blow this thing up a little bit so we can see it better. All right, let's take A here. So do you think we can draw a line that creates two identical right triangles? Well, let's just try. So yeah, these two right triangles look exactly the same. So that would be one. Now let's look at the polygon B. Do you think that we can draw one line and compose two identical triangles? So let's see, let's do this. Yeah, those triangles look identical. So let's move on to C. This one looks a little tricky. So do these triangles look the same? No, they don't. Whoop. Sorry, technology again. It gets me every time. So let's try this line here. Do these two triangles look the same? No, they don't. So we can't draw two identical triangles out of that polygon. So let's try D here. I'm sorry, I'm going to draw these lines back on A and B. All right, let's try D. Now, do these triangles look identical? Yeah, they do. All right, let's move on to E. Now, do these two triangles look identical? They look similar on first glance, but they're not identical, which means they're not the same. So let's draw the other line to see if maybe that one will work. Do these look identical? Again, they look similar, but they're not exactly the same. So let's look at F here. Do these two triangles look identical? Yes, they do. All right, last one, G. Do these triangles look identical? They certainly do. All right, so which quadrilaterals were we able to decompose into two identical triangles? Well, that would be A, B, D, F, and G. So let's look at those a little bit. What do we notice? So what is it about C and E when we drew those lines that showed us that we don't have two identical triangles? How do we know that? Well, these opposite sides here aren't of equal length. They're not the same length. So if they're not the same length, when we draw a line trying to compose two identical triangles, then those triangles wouldn't be the same. So same with C. These sides aren't the same length and they're not parallel. So when we draw a line across there trying to create two identical triangles, then those wouldn't be identical. So in order for a quadrilateral to be decomposable in two identical triangles, it must be what? Well, it needs to be a parallelogram. So it needs to have equal sides and equal angles opposite from one another. Okay, let's move down to the next. So here we have a little diagram that shows us a pair of triangles. Now we're going to work through a couple of these. We'll choose two pairs. This one you see here is labeled P, and we're going to use those to help us answer these questions. So which pair of triangles do we have here? We have P. So can we compose these two triangles into a rectangle or a parallelogram? Well, let's see. We're going to turn this one and then move it. Well, is that a rectangle? It's a square, yes, but a square is a rectangle. Is it a parallelogram? Yes. How do we know? It has four sides. Opposite sides were equal. Opposite angles are equal. So let's look at another pair. So what pair do we have here? We've got pair Q. So let's try this. I'm going to move this one over here. And then, whoop. Okay, that's not a rectangle or a parallelogram, is it? Let's try again. Sorry guys, you may hear that noise in the background. That is my dog scratching on the door trying to get in. So do we have a parallelogram here? We do. So we can compose these two triangles in order to find a parallelogram. So let's look at one more. R. So what do you think? Do you think we can compose a rectangle here? That's not a rectangle, but it is what? That's a parallelogram. How do we know? We've got equal sides. They're parallel. We've got equal opposite angles. So, what did we learn here? Well, a parallelogram can always be decomposed into two identical triangles by a segment that connects the opposite vertices. So what does that mean? Well, in our first exercise, we showed that we could draw a line, like you see here, in a parallelogram and create two identical triangles. So you see in this second one here, you draw a line across opposite, and there's two identical triangles. Again, you see that here. So a parallelogram, again, can always be decomposed into two identical triangles. And remember, how do we find the area of a parallelogram? Well, we identify one of the sides as the base, and then we draw a line perpendicular to that base to the opposite side. So also, we saw that we can compose a parallelogram or a rectangle out of two identical triangles. So as you see here, we've got this yellow triangle and we've got the blue triangle. Now we put those two together to produce a parallelogram, or to compose a parallelogram by joining those triangles together. And all these triangles are the same size, so you can see we can compose different shapes here. We've got a rectangle on the left, we've got a parallelogram in the middle, and then we've got another parallelogram on the right side. So again, here you see these triangles that are labeled F. We've got the yellow triangle here, and we have an identical triangle in the blue one here. And when we put those together, we can compose a parallelogram out of those two identical triangles. So what we're trying to show here is that the relationship between a parallelogram and identical triangles. And as we move forward, this will help us determine the area of a triangle, which we'll look at in a little bit more detail on Wednesday. But again, as you can see, we can decompose a parallelogram into two identical triangles by drawing a line from one vertices, which is the point here where the two lines come together, to the opposite side. Or we can compose a parallelogram by putting two identical triangles together. So I will post an exit slip later this afternoon for y'all to work on, and let me know if you have any questions, and we'll see you all on Wednesday.